Alright, this is part 16 of our 6-cycle oddball build series. In today's video, we are going to be making the governor bracket. A relatively simple, but surprisingly time-consuming piece to make. It came out perfect. I'm really happy about the results, but it actually took a while. I time-lapsed some of the video, I cut some of it out because, you know, no one's going to watch a 45-minute video of a part just spinning around in a circle on the lathe. So I trimmed some of the fat, got rid of some of the boring stuff, time-lapsed a bit of it, and showed you what you need to see to understand how this part gets made. But this is going to have two flyweights that open and close on it to lock or unlock the exhaust valve, which will allow the engine to free spin or make a combustion cycle and have spark and ignite the fuel and all of that. So again, at the end, I'm going to walk you through every step by step exactly how this all works and show you why it's a 6-cycle engine versus a more conventional 2-cycle or 4-cycle engine, and I'll walk you through it all. It'll all make sense whenever I'm done. Probably right now it's about as clear as mud. Hopefully whenever we're done with this, it'll be as clear as bottled water. So definitely stick around till the end. This is part 16, like I already said. I think we're going to have a part 17, and if we're lucky, part 18 is going to be the engine running, which will be super exciting. So I can't promise that. There may need to be 2 more videos of machining, and then that would mean part number 20 or 19. Part number 19 will be of the engine running. If it runs, let's be honest. This is a whole lot of work, and there's a whole lot that could have went wrong that I didn't catch along the way. So maybe it doesn't run. I don't know. But we will definitely find out. So as always, thanks so much for tuning in. I'd really appreciate it if you'd subscribe and share this video with some of your friends. Let's get to the live action on the lathe right here behind me. See you in the next video. Alright, let's get started on this governor bracket. The plans call for it to be made out of aluminum, but I'm going to make it out of steel because I don't think aluminum is the right move. So pretty easy. I'm going to start here on the lathe, finish it up on the mill, and then got to drill 2 holes. Man, that threw chips everywhere. Alright, so that is 1 1/4. It's actually a thou under, which I think will be alright. So the next thing I'm going to do is mark where my length is going to be. Which, like I said, is 594. Alright. So that's that marked, so we can come back to that later. But that is my like overall length of this part. Now we need to move the parting blade over. I think we need to feed in 281. Alright, that's our groove. Now we need to drill a hole in it. Okay, that's that hole reamed. Now we gotta bore. .282 deep. And we need to open it up to 3/4 of an inch. Set my stop up over here so that we can just run into that the rest of this. And I will tell you what, if you're like a hobbyist machinist like me, don't spend your money at all on mild steel. This is 12L14. This stuff turns so darn nice. It is without a doubt the way to go. That's currently a 1/2 inch, and we have to go to 3/4. $150 to go yet. Should be about 720. What? 715, so 35 to go. I was just running a pass across the bottom to clean that up. So that's all we can do on the lathe. Now we need to move over to the milling machine.
Alright, the first thing we need to do is machine a 3/16 slot all the way through that part, and we need to go 282 deep on that. So I'm basically touched off there, and we need to go 282 deep. I'm going to push my luck. This is a 50 thou depth of cut with a 3/16 end mill. Alright, now what we need to do is move back half of our cutter, or actually we need to move back the whole cutter, I think. Plus, these tabs are supposed to remain 1/16 of an inch. Let me see if this looks like it's going to be right. So that's 156. Yeah, so let me do some math real quick. 3/16 is 187. So we need to go back 250. And that should leave us a 1/16. So I'm actually going to go back 260 and leave myself a nice little cleanup cut at the end. Guess now's as good of a time as ever to check the math. Yeah, dead on. Alright, so I'm going to run back and forth on this side, and I'll bring you back whenever we are almost finished. Probably going to show you more on this side than anything. Try and get you the bird's eye view here. You can see we machined this channel back here. This piece is all going to get cut off as well. And then we're going to machine a channel out here to leave these two tabs to support our governor pieces. Alright, off camera, I'm going to cut the rest of these tabs off the outside because we don't need those. And then I'll bring you back. We have to machine 2 pockets in the ends of this. And that'll be this whole part. This is what I was saying about that little slot. You can see I cut that slot all the way in until it just kissed that inside groove that we cut earlier. Got that done on both sides. Now we just got to part this off on the lathe. Just wanted to show you real quick. I'm kind of shaping this according to the plans on the belt sander. It's really, I think, just a cosmetic cut, so you can see my scribe line there across the top that we're scribing, or that we're grinding to, and then you can see here the shape that I'm putting it at. Like I said, really just on the belt sander, not doing anything any more than that. I think it'll be good enough. But I got this parted off, and this is basically a complete part. I also drilled those 2 holes in it according to the plans. Not much to that either. Just show you real quick here what I used to shape this piece. So this is a 2x72 belt grinder. I built this a long time ago. I made a lot of knives, and this worked really well for it. And this is what they would call a small wheel attachment. This is all handmade. I made all of this for this belt. Well, I made the whole belt grinder, and I also made this. Each of these wheels are on bearings. You can see kind of how it works here, and then these are different size wheels for it. I think this is like 1 inch, 7/8, 3/4, 5/8, I don't know, something like that, but you get the idea. They all have bearings on the ends, roller bearings, so they can roll real nice. And this is a 1.5 horsepower 3-phase motor, and then inside of this cabinet is a variable frequency drive which converts single phase to 3-phase. This is the speed control, and then this is the on-off switch. But this thing is unbelievably handy in the workshop. You can tilt it. I actually used it tilted down like this just right now, so it can lay horizontally, and then you can work right here, right on that wheel, and it works really, really well. Just thought I would show you this. This is a set of laser cut parts, and then of course you have to weld and bolt everything together. I wish I still had the plans. I kind of would like to remake it. There's a few things that I would change about it if it were my design, which it's not, and I can't find those plans anymore, so it's kind of a bummer because this is a really, really nice machine. But there you go. That's how I'm shaping this piece. As you can see, it's pretty much perfect. It's really easy to grind to scribe lines if you take your time. There it is. Finished part.